All right. So for students of mine and public viewers out there, once you have arrived to this video lesson of mine right here, then I assume or allow me to assume that you have seen at least my introduction video lesson about how to take antiderivative, and essentially I call that the eventually at some point I refer to those as the indefinite integral, and then we formally learned before this point on some other video lessons about what a definite integral is. And so at this video lesson, it's going to be a short one here. In this particular lesson here, I would like to make a few clarifications so that in the later videos and as you follow and study along with me, especially for students who are studying with me right here, you won't, we will have a much better way to communicate in terms of the terminologies used. So in any course that I'm teaching, usually there has to be a point where I have to really clarify a lot of the terminologies being used. Okay, so just a couple of clarifications here that I want to point out. So first of all, at this point, about the terminology, the naming. So an antiderivative, you already knew. For an antiderivative. Okay, so now we have already learned that there's a new language for that. It's the same as being regarded as an indefinite integral. Okay, and then of course, now the formal symbol for that is just this sign right here without the lower and the upper limits number, and then there's a function, and then there's that dx right here. So this is now, we call that, it's the antiderivative of f of x, or it's the indefinite integral, or even for short, just this whole problem is also referred as an integral. Okay, so an integral is usually, or is generally referred to an indefinite integral. Okay, because even if you are taking, as you have learned through the fundamental theorem of calculus, then it has been pointed out through the fundamental theorem of calculus that eventually to take a definite integral, you have to go through that process as a first big step to find the antiderivative. And that was the reason why I explained at the end of some of the earlier lecture that because of that reason, now antiderivative is legally accepted as being accepted or understood as an indefinite integral. And so now even for short, just an integral, when you hear it's the name of a problem, that means the kind of problem where we find the antiderivative of that of a specific given function. Okay, and so now that's just the name of the problem. We call it an indefinite integral, or it's an integral in general. But now sometimes you might even hear me use some terminologies as following. You may hear me use the term integrate. Okay, integrate. All right, so it's now a verb. I don't intend for this to be an English course, but so it's a verb. So what does that mean? So the term integrate now, specifically for calculus learning, it means we take the integral. Okay, we take the integral or find the integral. That's what integrate means. So we take the integral or find the integral, and now of course integral is the antiderivative or the indefinite integral of the function f of x. And so to be formal, a lot of time I say, integrate the function f of x, integrate the function g of x, and all that. That means we take the antiderivative, or we find the antiderivative, or we take the integral, or we find the integral of that function, the indefinite integral of that function. Okay, so that's another terminology that I would like to point out. And then of course the noun form of this. So the verb here, the action here is to integrate. But now sometimes we can refer to the whole process of taking the antiderivative as the integration process. So integration, okay, is just the name of the process. To take integral. All right. And so that's just a couple of clarifications about the way how I use the language and how the mathematicians in general use the language. And so now there are other important highlights that I also would like to clarify. So now when we specifically look into the symbol for an integral problem, I started out explaining that this is only one package, but now after we've gone a long little journey right there, prior to the point right before we entering this video lesson in particular, then we've learned that in the end, this now is called an indefinite integral, and it's all due to that reason that the fundamental theorem of calculus stated that in order to find a definite integral, then we have to go through the process of antiderivative and all that. So because of that, actually, now this symbol is, this sign and the dx here is not only one package symbol as in the first time when I introduced that anymore. So I still remember clearly that if any of you search back in any of my earliest video that I taught about the whole idea of taking antiderivative, and at that point I wanted viewers to take the whole package that I circle here with the red ink here as one package as an instruction to indicate that we want to find the indefinite integral of this given function. But now after some understanding, especially after we have gone through the video about how to find a definite integral, and then from that idea we merged back into explaining how this is an indefinite integral simply because it doesn't have the two limits low and high here. Then now I have to really emphasize again, even though without the two limits, but we can still take that concept that the relationship or the connection between the two expression here. So dx now is actually an expression. It's not only part of the whole symbol like how I indicated earlier. So this means it's some expression and it's being related with this. It's being connected with this function as a product here. So that's something I need to really emphasize right there. So that after this point and when we go on to any other kinds of problem that essentially deals with an integral problem, then it's going to be a lot more flexible for you to understand the solution. Okay, so it opens a new door for communication between instructor and students of how the problems can be done, especially this understanding. Because see, for a definite integral, the reason we can adopt that idea as it is being a product here simply because see, for a definite integral, then this means, see, I've been explaining this is height of the function at some instant x value and multiply or in product with a thickness dx, and that's how I explained that. But that was for definite integral. And so now from that point on, when we go back and think of this indefinite integral, the only difference now is that we never had that lower and upper limits for indefinite integral. But so that we can still let that means being a product there. Okay. All right, so that's another clarification. And so now, upon clarifying this understanding here about the relationship between, so this is now an expression, it's a dx. So the consequence of this now is that a lot of times you might see a problem like this. Now I'm bringing this up. Now it's just what I'm about to bring up now is just to give you more experience when you look at a problem and be able to identify your problem a lot more easily. Okay, and so, well, in my style of writing the problem, then usually I write clearly that we have the function, say, a function 5 over x, for example, with a dx. Then in my style of writing, I usually write the function separate out and I keep the dx out. Maybe because it's consistent with the way how I started out explaining about this whole notion, this whole symbol as one package in the beginning. But now, for the rest of other mathematicians, and including me, and now you got to become a little more mature than what I taught you earlier. Then, upon accepting that this is a multiplication, then here, in case that you're working with other professors or you're working with textbook authors, sometimes or quite a lot of times you will see the same problem will be written as following. It's an integral sign, but 5dx over x. It's the exact same problem, but so why? I mean, how can this be? It's simply because we have now accepted and understood, and now we have accepted that and understood that the relationship or the connection between this expression and that 5 over x function is a multiplication. And so if it's a multiplication, then some textbook authors, quite a few of them out there actually, decide to write the whole problem as something like this, which is, they put the product all over in the numerator of a fraction. So it's still that exact same problem, just slightly different way of expressing it. Okay? And so that's another clarification that I would like to point out. And I highly recommend be able to flexibly understand the two different ways, but more primarily be able to understand now that it's legally accepted, it's legally understood that the dx is an expression that connects with your main function that you are taking antiderivative on as a product. Okay, that is a product there. All right, and so now, from any other later videos, when I post a video later teaching about new skills on integration problems or to integrate a function, then I can start assuming that my students or my viewers who follow along with these videos will understand that these are multiplications between the two the existing expressions here. Okay, so that's one more clarification I would like to make. And so now, let me navigate back to my other board, and I'm going to bring up the last clarification that I would like to make here. Okay, so I have seen quite a few textbook authors in these days claiming that, or stating that when you are doing an integral problem, when you are integrating a function, this x right here is a dummy variable. Some part of it I do not agree. Okay. In some part of that, I do not agree, because maybe it could be me that I misunderstand their intention of what they mean by saying that the variable is dummy. But here's how I see it. I see that being able to indicate the variable is quite important actually. But this is what I want to explain right here. Okay. Yes, maybe that the variable itself here, it could be to those authors who say things like that. It could be because we can name that whatever we want. We can name the variable whatever we want. That's probably what they mean. That's why it's called dummy, because it kind of brings some understanding that the variable is not important. Okay, so yes, if it's only at that part, I agree, and you should agree with that as well. Whatever the name here, you can call that the t variable here, the x variable, or the z variable. Yes, that's fine. But here's the important part that I would like to emphasize on top of that. Now, if you call your variable x, or how about, I'm getting tired of x, let's call that w. Okay? If your main function, or if you're intending that the main function of yours takes variable w, then the d thing here, the d expression here, has to be dw. Okay? And so that's how I see it's not as dummy as you may think. So I got to clarify, so maybe it's not the author's fault for saying that it's dummy, but maybe their intention to say is that dummy just means you can name it whatever you want for the variables here. But when it gets to, but the next thing I would like to emphasize, the next emphasis that I would like to make here is that whatever the variable's name you decided for your function, the d expression here must stays consistent with the main variable of your function. That's the one important thing right there. So why do I emphasize this? Because here's the thing. You see, when you're looking at a formula, a lot of times formulas in these days are all over calculus textbooks. And so you will see a lot of formulas as following. Okay, so how about You see something like this. Okay? It's an integral problem. And then if we see this dx right here, if we attach that problem with the d expression, and that's why the d expression is extremely important. So now the d expression now, since the x here is associated with the d expression, and that means, see, the reason now I really emphasize is because variable is in the end a letter. So that's a letter, that's a letter, that's also a letter. So which one of these really is? I mean, simply without a clear indication, then which one among these three letters is the main variable of the expression? And that's what I'm saying right there. And so now with the existence, I mean with the coming along of the d expression here, then it clarifies clearly that, hey, three different letters, but our main variable is this guy right here, is the x. From there on, so once you have identified and focused your attention to the main variable because you have had that indication, then what do you see about the rest of these other letters? They are now either coefficients or constant term. That's what it is. Like, for example, you have a 2x plus 1 with a dx. That's constant term. That's coefficient. And so generally as a formula, then of course we have no other better choice rather than writing that as some mx plus b, for example. But so now viewers or readers of a formula will be thrown into a whole box or a whole chunk of letters. So that's why relying on this indication with the d expression is extremely important, in the sense that it indicates among so many letters here which one is the main variables. And once you have identified the main variable, the rest are all being regarded as either constant term or coefficients. Okay? And so that's the reason why for this particular problem right here, for this particular setup with the three letters here, the mx plus b, now if it's a dx here, then your final expression here would be treating m as a constant coefficient, then you can just simply do according to the power rule, mx squared over 2 plus bx, because see this bx term, this term b, which was a constant term, now becomes a bx right there, and then you add a constant c to that. Okay, and that's, so we come to this derivative simply because we treat x here as the main variable. All right, so the same mx plus b, three letters involved. But now if I'm looking at the db right here, it's a d expression, but the letter b is attached to it, is associated with that d expression. Okay, with that d expression, and that means now the main variable here, is b. Okay, so really anything else, maybe even as a product or anything like that, but the whole thing here is only a constant term. You see how the role of the letters get switched around, all dependent on what this expression is. That's why it's extremely important. So maybe when textbook authors say that the variable in an integral problem is dummy, they could have clarified a little better about that. I probably see their understanding, but that way of writing it, of making a statement, could be a little dangerous, making students think that we don't need to clearly identify the variable, but it's important to identify the variable expression. Especially the variables that being indicated with your d right here. Okay, and so now with a problem like this, the db now indicates that b is our particular variable. So now I'm going to see only b as a variable. The coefficient with this variable here is the coefficient 1. Okay, well algebraically that's what it is. And now all of that here as a product, m times x, but one whole package there is a constant term. And so now your antiderivative here is supposedly mx b, the variable, plus, now that's a 1b, so now it's going to be a 1/2 b squared. You see how the difference in the answer is? Okay, and then plus a final constant c, a different constant. So see, same starting expression. It's the exact same starting expression, but depending on whatever your d expression, it will drive your final antiderivative, your final integral, into a completely different answer. All right, so be careful with that. And for now, at the end of this lesson, I mean of this particular video lesson here, you probably don't see much of the impact there, but later on when you advance to a higher course in mathematics, and when all of that concept about taking an integral, when all of that come back right there, you will understand why it's so important to clearly understand the role of your D expression here, and especially the letter that's attached with that, okay, or that's associated with that, okay. All right, so that's everything I need to clarify in this particular short video here, and then I'll see you at some other video.